So good evening, children. Today's class, we are going to discuss about the chemical properties of ammonia. We already discussed all the basics about ammonia, right? Why ammonia got this particular structure, which type of bond acting between NH3, basic preparation of ammonia, industrial preparation of ammonia, laboratory preparation of ammonia, Haber's process, reactions, promoter, catalyst, all the concepts we discussed, right? Any doubts in that? Concept is strong for everyone. Fine. Now, today's class, we are going to discuss the chemical properties of ammonia. What are the chemical properties of ammonia? The first chemical property is nothing but ammonia gas is basic in nature. Children, already this idea you guys got early rules. How? When I discuss about catalyst, I explained that we are using calcium oxide as the catalyst, right? Why we are using calcium oxide as a catalyst? In case of HCl, we didn't use calcium oxide. Instead of that, in case of HCl, we introduce concentrated sulfuric acid. But in this case, we are using calcium oxide for ammonia preparation. Why? The reason is nothing but calcium oxide is calcium oxide won't react with ammonia. All other will react. The reason was ammonia is basic in nature. Understood? Any doubts? So listen carefully, children. The first property of ammonia, I'm starting with this particular term. Ammonia gas is basic in nature. An aqueous solution of ammonia is basic in nature. Dry ammonia is a covalent molecule. It is neutral. But the liquid form of ammonia, that means aqueous solution, is a weak base. The basicity is due to lone pair of electron in nitrogen atom. So listen carefully. From this statement, you guys can understand ammonia is basic in nature. How ammonia got this basicity nature? The reason is NH3. It is nothing but a covalent bond, right? Nitrogen is bonded with hydrogen by using covalent bond only. But there is lone pair of electrons also. We have bond pair of electrons and lone pair of electrons, right? We have three bond pairs of electron. Nitrogen is bonded with hydrogen by using three bond pairs of electron. Along with that, we have lone pair of electron, which is not bonded, right? This lone pair of electrons of nitrogen is the reason behind basic character of ammonia. Understood? This lone pair of electron is the reason behind the basic character or basic nature of ammonia. So an aqueous solution of ammonia is generally basic in nature. That we guys can understand. So listen carefully. Dry ammonia is a covalent molecule. It is neutral. So children, there are two types of ammonia we are going to introduce here. The first one is nothing but dry ammonia. And the second one is nothing but liquid form of ammonia. Dry ammonia, if you consider dry ammonia, that particular ammonia is neutral. There is no basicity, there is no acidity. If you consider dry ammonia, it is neutral only. There is no basicity, there is no acidity. But when you consider the liquid form of ammonia, that is nothing but aqueous ammonia or aqueous solution of ammonia. They are weak bases. Understood? Basicity is there in case of aqueous solution. So we can call that aqueous solution of ammonia is basic in nature. Understood? Any doubts? Once again, I repeat, we are talking about the basic nature of ammonia. The basic nature of ammonia is the reason is nothing but lone pair of electron. We have one pair of electrons and lone pair of electron. Nitrogen has lone pair of electrons. This lone pair of electrons is the reason behind the basicity of ammonia. So when you consider, there are two types of ammonia we introduce here: dry ammonia and aqueous ammonia. So what do you mean by dry ammonia? There is no presence of water, liquid. What do you mean by aqueous ammonia? The liquid form of ammonia, we call it as aqueous ammonia. So in this case, dry ammonia is neutral. There is no basicity, there is no acidity. But liquid form of ammonia is basic in nature, weak base. Understood? Fine. Next one. Listen carefully in between. I'll ask questions. Okay. Now, the dry ammonia gas or ammonia in the liquefied form is neutral to dry litmus. We already explained that, right? Dry ammonia is nothing but neutral only. Now, how you guys are able to understand they are dry? Ammonia is neutral. You just introduce a litmus paper. When you introduce a litmus paper, if that ammonia convert into blue color, it shows that it is basic in nature. If it is converting into red color, it shows that it is acidic in nature. But in this case, if you consider dry ammonia, if you introduce a litmus paper, no color change. That means that particular liquid is, sorry, that particular gas is neutral in nature. Ammonia is a very weak base in case of aqueous solution. Remember that also. Its basicity is due to the lone pair of electron on the nitrogen atom in ammonia. Any doubts? All these terms already sir discussed. Okay. Is it okay? Fine. Just read that once again. Now we are going to talk more about the basic nature of ammonia. Just now I given just a introduction about the basic nature of ammonia. Now sir is going to talk more about the basic nature of ammonia. Children, what do you mean by aqueous solution of ammonia? That is nothing but you take some ammonia, into that add some water, add some liquid, right? What do you mean by aqueous solution of ammonia? Children, you take some ammonia, into that add some water, then this particular reaction will happen. NH3 plus H2O will give NH4OH. That is nothing but we call it as aqueous solution. Understood? Ammonia you take, into that add water, you guys will get NH4OH. This NH4OH in reality we call it as aqueous solution. Is it okay? Now, this aqueous solution is alkaline in nature and it acts as a weak base. Since it undergoes partial dissociation aqueous solution, then it will give a hydroxyl ion in low concentration. What do you mean by that? Children, this is nothing but opposite reaction only. We are talking about the basic nature of ammonia, right? What do you mean by basic nature of ammonia? When you consider dry ammonia, it is neutral. When you consider liquefied ammonia, liquid form of ammonia, you guys understood it is weak base. How it become weak base, that we are going to understand. For that, children, you take some ammonia, into that ammonia add some water, we got NH4OH. This NH4OH is nothing but aqueous solution of ammonia, which is alkaline and which has a weak base. Why they have weak base, you guys know that. Why? Lone pair of electrons in nitrogen case. Now, if partial dissociation is happening in case of NH4OH, then what happens? NH4 plus OH minus will come, right? So when this NH4OH undergoes partial dissociation in the presence of aqueous solution, then it will give hydroxyl ion in low concentration. Hydroxyl ion means OH minus. Just the partial dissociation of NH4OH, NH4 plus OH minus you guys will get, right? So partial dissociation will give hydroxyl ion solution in low concentration. Fine. Next one. This is the reaction, children. NH3 ammonia plus water will give NH4OH. That is nothing but aqueous solution of ammonia is formed. Now, this NH4OH is undergoing partial dissociation. Then what happens? You guys will get NH4 plus OH minus. So NH4 plus is nothing but ammonium ion and OH minus is nothing but hydroxyl ion, which is alkaline in nature. What do you mean by ammonia? What do you mean by ammonium? Sir, already discussed, right? What do you mean by ammonium? Ion. What do you mean by ammonia? Understood? Ammonium is nothing but just an ion. Ammonia is a. So you guys understood what is a partial dissociation? First, we are converting into aqueous solution. For that, into ammonia, you guys are adding water and you guys are getting NH4OH. Now, partial dissociation means NH4OH will become NH4 plus OH minus. You guys will get NH4 plus as the ammonium ion, OH minus as the hydroxyl ion. In this hydroxyl ion are alkaline in nature. Hence, you guys are getting alkaline in nature, right? Hence, you guys are getting basicity also, right? Now, the alkaline behavior of aqueous solution NH4OH is due to the presence of hydroxyl ion. This is just now I explained, right? So why you guys are getting an alkaline nature for NH4OH? They will ask. The reason is nothing but when NH4OH undergo partial dissociation, You guys are getting ammonium ion and hydroxyl ion. This hydroxyl ion is the reason behind alkaline behavior. Understood? Is the reason behind alkaline behavior. Weak base means lone pair of electron will be. Alkaline means it is hydroxyl ion presence will be there. So what do you mean by weak base, children? Lone pairs of electrons are the reason behind weak base. Just now we discussed that, right? In case of aqueous solution of ammonia, we have weak base. That means lone pairs of electrons were in that case. Now, alkaline nature means the presence of hydroxyl ion. Understood? The aqueous solution of ammonia turns red litmus into blue. The aqueous solution of ammonia turns phenolphthalein into pink. This too confirms that it is nothing but a weak base. Understood? Aqueous solution of ammonia is a weak base. Children, once again I will repeat. We have two equations. The first equation is nothing but aqueous solution formation of ammonia. For that, take some ammonia, add some water, you guys will get NH4OH. Fine. Now this NH4OH is undergoing partial dissociation. When it undergoes partial dissociation, you guys will get NH4 plus OH minus. This NH4 plus is nothing but ammonium ion. OH minus is nothing but hydroxyl ion. This hydroxyl ion is the reason behind alkaline nature of ammonia. Sir, how this presence of hydroxyl ion is the reason behind alkaline nature? For that, I given one small idea here. Whenever you have hydroxyl ion presence, then it will be alkaline nature. When lone pairs of electron presence is there, then it will be a weak base. So the alkaline behavior of aqueous solution is due to the presence of hydroxyl ions. Now we need to confirm aqueous solution of ammonia is a weak base. For that, you guys just introduce a litmus paper, red litmus paper, just introduce to this aqueous solution of ammonia. Then it will be converted into blue. This is first confirmation for a weak base. Second one, you take some phenolphthalein, it will be converted into pink. These are the two confirmations to prove the aqueous solution of ammonia is a weak base. Understood? I hope from your school also you understood these things, right? Yes. Fine. Please read this. Now listen carefully. Listen, Arthur, listen. So now we are going to discuss another topic that is nothing but liquor ammonia. When you guys hear about liquor, I know what will come in your mind. This is not that, okay? Liquor ammonia, nothing is coming in your mind. OH is alcohol. Since I taught him organic chemistry, he remembered that OH is alcohol. So other things he won't remember. Anyway, it's fine. So now we are going to discuss another topic of that is nothing but liquor ammonia. Listen carefully. What do you mean by liquor ammonia? It is an aqueous solution of ammonia in water. Understood? Aqueous solution of ammonia in water, we call it as liquor ammonia. Understood? So what do you mean by aqueous solution? Just now you guys understood, right? What do you mean by aqueous solution? Shazia, what do you mean by aqueous solution? Yes. So that aqueous solution in water, aqueous solution of ammonia in water, we call it as liquor ammonia. This liquor ammonia is also known as liquor ammonia fortis. Understood? Liquor ammonia, another name is nothing but liquor ammonia fortis. This particular solution is a saturated solution and its specific gravity is 0.88. These are general characteristics of liquor ammonia I'm giving. Understood? So listen carefully, children. We are going to introduce our topic that is nothing but liquor ammonia. Liquor ammonia is nothing but the aqueous solution of ammonia in water. We call it as liquor ammonia. Understood? Aqueous solution of water. Just now, sir explained what do you mean by aqueous solution of water, right? So aqueous solution of ammonia. That aqueous solution of ammonia in water, we call it as liquor ammonia. Another name for liquor ammonia is nothing but liquor ammonia fortis. Understood? Another name of liquor ammonia is nothing but liquor ammonia fortis. What is the characteristics of liquor ammonia fortis or liquor ammonia? that is nothing but it is a saturated solution. Second one, its specific gravity is nothing but 0.88. Fine. Now we are going to discuss how you guys are preparing liquor ammonia. How you can prepare liquor ammonia. Don't go to your home and tell your parents that sir taught it today how to prepare liquor and all. Understood? I'm going to discuss about how to prepare liquor ammonia. Understood? Ready? Don't try today, okay?
Yes, sir.
Okay. You try or you won't try?
I won't try.
I know science you want to explore, but don't explore by using ammonia. Okay? Next one. Preparation of liquor ammonia. Children, listen carefully. Preparation of liquor ammonia. How you can prepare liquor ammonia? By dissolving ammonia gas in water using a funnel arrangement. In HCl chapter, sir already introduced what do you mean by funnel arrangement. Do you remember that? Funnel arrangement we explained perfectly. Now, according to that funnel arrangement, we discussed how you guys are preparing HCl. Similar method, by dissolving ammonia gas in water, by using a funnel arrangement, you guys can prepare liquor ammonia or liquor ammonia fortis. This preparation is similar to the preparation of HCl from HCl gas. You remember that? You remember that, right? HCl chapter funnel arrangements are discussed. The same concept only, but here you guys are preparing liquor ammonia by dissolving ammonia gas in water by using a funnel arrangement. Understood? So I hope you guys understood what do you mean by liquor ammonia fortis, what are its general character, how you can prepare liquor ammonia. That is nothing but by dissolving ammonia gas in water by using a funnel arrangement. This preparation is similar to the preparation of HCl from HCl gas. Understood? Any doubts? Fine. Now, ammonium salt. This concept we will discuss now. Please read this, children. Now, we are going to discuss ammonium salts. Children, what do you mean by ammonium salt? Very important concept. I hope your exams they ask this question, right? Ammonium salts. Children, ammonia in gaseous form, you guys know. Ammonia in aqueous solution, you guys know, right? Dry ammonia is nothing but ammonia in gaseous form, right? And aqueous solution of ammonia is nothing but liquor ammonia. Go, man. See, ammonia in gaseous form is nothing but you guys know dry ammonia, and aqueous solution of ammonia also you guys know, right? That is nothing but adding water into ammonia. These two types of ammonia or dry ammonia or aqueous solution of ammonia neutralizes acid forming respective ammonium salt. So when you consider some ammonia into that, when you introduce acid, what happens? It will form one ammonium salt. For example, to NH3, you guys are adding H plus ions, then you guys are getting NH4 plus. So from this, we can understand that into ammonia, whether it's an aqueous solution of ammonia or a dry ammonia, into that, if we introduce an H plus, that means an acid ion, you guys will get an ammonium salt. Ammonia being a weak base accepts the hydrogen ion to form ammonium salt. So how this is forming, how this reaction is occurring, we are explaining. Ammonia is nothing but a weak base, right? So into that weak base, if you guys are adding acid, they are trying to become neutralized, right? They will try to become neutralized. Because of that process, you guys are getting ammonium salt. For example, NH4 plus. It reacts with acids to form ammonium salt. Now, preparation of ammonium salt. There are two types of preparation of ammonium salt, by using ammonia gas and by using aqueous ammonia. This topic I'll discuss next class. So listen carefully. What do you mean by ammonium salt, children? You can take two types of ammonia, that is nothing but ammonia gas, such as dry ammonia, or you can take aqueous solution of ammonia, that means ammonia in water, liquid form of ammonia. Any two types of ammonia you can take. Into that ammonia, if you introduce an acid ion, that is nothing but H plus ion, you guys will get ammonium salt. For example, you can take NH3. Into that H plus you guys are introducing, you guys are getting NH4 plus. Now listen carefully how this reaction is processed. Ammonia is nothing but a weak base. We know that. Into that ammonia, if you guys introduce acid, this ammonia will try to become neutralized. Because of this reason, you guys are getting ammonium ions. It reacts with acid to form ammonium salt. There are two types of preparation of ammonium salt. The first one is by using ammonia gas. Second one is by using aqueous ammonia. I hope till this my children understood the concept perfectly. Any doubts regarding this? Any doubts? Be free to ask. So thank you, children. Have a nice day.